So we're gonna quickly go through this because it's been a while. But I think that it's basically just discussing this X type or X lens, I guess. So so we provide it with an index, and it builds a traversal over the value at that location. Okay, so basically, I think this is just a maybe. And so typically the way I do this is we'll just run stack gh down here. And then we can just start running these things. So I think that ix0, yeah, is going to return the second element, or sorry, the first element, right? That's the zero. The Borg is the 0th element. So if we just look at B down here, yeah, we get that. C will be nothing. C prime should fail. Oh, interesting. What does that one do? Uh, this is weird. So this is view, right? Pretty sure. Yeah, but there's nothing there. So I guess you get some default value. I don't know, something like that. Okay, so this is kind of interesting. I sort of expected it to fail, but maybe because A has the type string, it just says there's nothing there. That's kind of the way that it works. Um, so we can also change things. So if we do D, we're saying uh, at x1 set Vulcan. Yeah. Okay, or we could try and set this. I wonder what this does. Nothing, I guess. So we can see down here that it doesn't do anything because it doesn't know what to do for a similar reason that this turn returns nothing. Okay. So now we have these benders. Then apparently you can look at keys through a map. So that's cool. So then we have G, which is this. H, which is nothing because it doesn't exist. I don't know what Sokka is, but must be a bender from what is this called? From the Last Airbender, maybe. Okay. Um, what's this one doing? Okay, so indexable structures are like non-empty lists. Seek, I think we looked this up, but I don't remember exactly what that is. We know what a vector is. We know what sets are. How would you set a value of a set? Can you do that? I'm kind of curious now. So if we had import data set, um, something like, um, no, I don't. Ban. Bye bye. Okay. So set dot. Oh yeah. So let's do qualified as set. Then we can just do AA equals set dot from list. Like 1, 2, 3. And then we should have AA. And then I guess we can also import data lens. Is that what it's called? Control lens. Sorry. It's been a while since I've done any lens code, so bear with me while I'm sort of remembering how to deal with this stuff. Okay, so we have AA, and then we want to see if we can set 1 um, to, I don't know, 4. What is, it's probably complains. Because, right. But so because its value is a unit, it's unsettable. That makes sense. What if we do like identity or something? So what is that? I think that's in data functor. I forget where that is. Right. I don't have Google. I have Brave. Okay, I gotta fix a few things. We need to pin this to the screen. By pin, I mean F6. It's Alt F6 on my keyboard. I don't know. That's something in um, XFCE to like pin things to the screen so they're always on it, no matter what workspace you're on. Anyway, I think identity is in like, oh, data functor identity. Isn't that what I did? Oh, I need another. Okay. So import data functor identity, and then we could say ident is identity no of oh. Now let's pick just a number. And then we can just look at ident here, just identity 0. What's the type? I think by default we get a num a. Hey Lumi, how's it going? How are things? And then we're gonna try and set this thing. So ident, we x. Okay, so at x unit set 2. Sure. Thank you. I'm sorry. That's my bad. Usually I'm good about changing it. Um, optics by example by Chris Penner, chapter 8, indexable structure. Thank you, Lumi. I totally forgot. I haven't changed it in a few days, I suppose. Can we change this to anything? I can change the type, I think. No, I can't. Yeah, it has to be because it's a num. What if I make it specific? I don't think this is gonna work, but I want to try it. Yeah, so it's gonna complain about integer versus like string basically. So that's fine. I'm not worried about that. I was just curious. Okay, so anyway, that makes sense. This one was kind of weird, like identity. Set was also kind of weird, right? Because it has a unit value, so you can't really set it. Actually, can I set it to unit? I bet I might be able to. Where'd that go? Yeah. So what if we index this thing? Yeah, sure, because we're basically doing nothing because it doesn't have an A value. So you can set it back to unit because that's essentially doing nothing. That makes sense. Interesting. Okay, so we got that done. We looked at a few of these other indexable structures. So cool. So here we are trying to index, I guess, the H out of this. So let's look at I. Yep. So we're the lens is focusing on a character. It mentions that down here, so that makes sense. For a byte string, I imagine a very similar things happens. We're just looking at the H, which happens to be 104, which we can prove by using what is the function? To enum H. There you go. From enum, the other one. Um, okay. We can. What is this one doing? So we're getting the element, the E. Is doing. I forget what this function is. I think it's like over or traverse of. What does this do? Oh, cool. But I think that this is called traverse of. See if we can find it. So we want to find percent tilde. Oh, let's remember what page we're on. 172. Let me write that down because I'm going to forget it. 72. And let's just poke around it. Yep, traverse of has an infix version. Percent tilde. So this is traversing this list at index 1 and replacing the character with all of the characters from this list. So that's pretty cool. Kind of a weird thing to do, but you can do it because you can do whatever you want with lenses. At the kind of view that we want here. Okay. So we can also index trees via a list of two indices. So I guess we're saying index of the first subtree. Okay, so what's M? Oh, well, that's not particularly useful. So this is this the first label, this one, and then two. So we're gonna get the left side of this tree. How is tree defined here? Rose tree. Sure. I don't remember what a rose tree is. Oh, okay. Apparently like this. That's useful. So does this mean we're gonna get four? Just seven. One index of the first subtree. Oh, is this supposed to be like 1 1? Is that the thing? So 1 1 would give us six, I guess. Okay, yeah, I guess that makes sense. Um, so pictorially, I guess we're going 0 1 0 1. Wait, but how did the two work? It must label this one if we put a seven, because I think we put a seven down there. Oh no, this is list of lists. So what we did before was just a second. Let me freehand draw this. I'm not gonna try and like do a good job. So is this freehand? It's freehand. Sure, that's totally fine. I don't care. So what we have is 1, 2, 3, 4. Oh wait. So that goes, that goes, and then so this is 4, 5, 6, 7. That's what we had this time. So subtree 1, this would be 0, this would be 1, and then this would be 0, 1, 2, or 1. So if we did 0, 1, we would get 4. Let's see if that's actually correct. Let me put 7 back here as well. So node 7 empty list. And then we're going to say 0, 0. Is that what I just said? Oh, no. This is supposed to be a 0. Sorry. By the way, I should be getting my tablet soon. We're going to have to figure out how to get that thing wired up and quick scene transitions between those things, because that would be useful to okay, so anyway, 0, 0 should give me 4, I believe. That's our thought process. So let's try that. N. Yep. And then if we do 1, 1, that should give us 6. Perfect. Okay, we got it. So we'll just leave this. Good. I don't need this anymore. That was just quick drawing. Perfect. Okay, we talked about this. Nice. And then if you try to get something that doesn't exist, no, it doesn't matter. You can just run it yourself. All right, so this one is really weird. Indexing into a function runs the function with the index as input. That's wild. So O runs reverse on the input. I'm not sure where you would use this, like where this becomes important, but it's certainly interesting. Okay, so this one's saying do this thing, which is going to reverse password, and then just say you guessed the magic word. Wait, doesn't that just, so what is P? Doesn't P just run? Isn't this set? Okay, so the type is a function that takes a string to a string, I guess. So if you're setting, this is string to string. Index with password. And then if you're able to get that index, you're going to set. Otherwise, it's going to reverse the thing. Weird. Very weird, but okay. Inserting and deleting with at. Okay, so we have Q What does Q do? I guess it just allows you to use this. What is F again? So I guess this is going to, R is going to remove the Zuko. Yep. Um, S is going to add hello world. Yep. And then S prime is going to do the same thing. Yeah. Okay. How does S prime work? That's interesting. I guess it's just the way that maps work, I would guess. But I'm not 100% sure. Okay. Great. This is cool. Oh, okay. This is actually different than I was expecting. I think that. Oh no, that. Oh right, this is view. Okay, so this is a set. Oop, I went way too far. I'm sorry. This is a set. Um, that wraps this thing and adjust. So this is just a quick, quick write for that. Cool. All right, all right. Uh, both set them to just. That makes sense. Um, Deletion is a common operation too. The lens library has sans as a helper to easily delete elements. Cool. Manipulating sets, primes. We're gonna see if 5 is a prime. So I guess it's gonna just print yes or what the heck is this doing? U is gonna print nothing. And then what does V do? Oh, sure. Okay, so V adds 14 as a prime, although that doesn't make any sense for obvious reasons. Okay, so then we went through these questions. So Larry Curly Moe, change 1 to Wiggly. Wonderful. Um, yeah, so we were given the output and we just have to fix this thing. So um, the output is Superman. What's HV? Oh, here it is. Yeah, so Spider-Man, we want to add Goblin, so that's all this is doing. We could have used dot question mark with Goblin, or sorry, yeah, question mark tilde Goblin would do exactly the same thing. But again, we're filling the blank here. So oh, actually, oh, no, it's right there. Yeah, so that's X. So this piece could be replaced if we wanted to. Okay. So this is Sans will delete Superman. Wonderful. Um, EEIOU. So this is adding Y. So that's what this adding Y and removing I. So that's what it does. Wonderful. Two, use X and at to go from input to output. So we want to take gum out. So we set this to nothing. Um, and that's a map. Mm-hmm. Then ice cream becomes 5. So that's what this is doing. And then we take soda and add 3. Cool. Easy. Okay, so custom index data structure. So this is cyclical indexing. So it's like we're just going to cycle through ABC over and over and over and over again. Forwards and backwards, so we can do positive and negative numbers. Sorry if that was really loud. Okay. Um so mhm. So new type cycled A is going to be a cycled of list of A. Sure. This is some type magic, um, which is basically finding uh the families for okay, work again. It allows GHC to pick a version of the IX uh lens, I believe. Start, middle, or end. Oh, of the stream? Start. We've only been streaming for a half hour. I assume that's what you mean. Um, which you could grab with uptime. Yep. So yeah, we just started, basically. Excuse me. So anyway, once we have this thing, then we can define this ixt thing, which basically just allows us to oh well that's true too. But yeah, so I'm gonna start streaming probably a little bit later, which I think is actually good for you, if I remember correctly. Um because I like I don't finish work until 6 instead of 5. Like I was trying to start streaming at 6 or 6:30 for quite a while, but that's just not working anymore because I don't finish work until 6 and I gotta cook and stuff like that. Okay, so all we're doing is basically converting our uh yeah. So it's I mean, I guess it's not that much different, right? Cuz you would have been in the probably mountain time, I guess. Uh just give me 1 second. I'm pretty sure that's right. Sorry, I'm a little distracted. Something something just happened for work. Okay. Anyway, sorry about that. Um you're in Kentucky, which I guess is uh central. Oh, yeah, okay. So Eastern. we're in the same time zone. So yeah, great. So anyway, I'm gonna probably try and start around 7 or 7:30. Uh, all right. Very distracted at the. I apologize. Okay. So we have this, and then basically we're just converting our index to the modulus with the length, and then that way it just goes from 0, 1, and 2. But if I don't think this works, does it work with -1? Did we decide? I guess it must work with -1. Um, okay, I haven't really thought about moduluses with negative numbers. -1, so it's like -1 mod 3. Oh, so actually this is totally fine. It can just do negative numbers. Uh, all right, cool. Here we go. So B prime, we did that. We're good to go. What's the difference here? Okay, so remember from the chapter on custom traversals that the traversal prime type synonym can be expanded like this. Oh, right. So I do not remember these types very well. I think that's going to take me. I still don't. I don't know. I need to do something with the types here because these don't. I still don't feel like comfortable with the types. Okay. Um. All right. So we have an address. I think we're going to make some custom indices. We have an address component, which is the index for an address, and then its uh, type is just a string. Which what is it going to do? Next. Oops. So what's going on here? We need the instance declaration for fixed, but can leave the implementation blank. It will be implemented automatically in terms of at. That's weird. How does that work? Oh, there's probably just a default implementation, and that default implementation is in terms of at. So as long as there's at, then it can just use at. So that's probably fine. Okay, and then basically we're just saying, given an address component, just give us a lens, which is building, which I guess is the. Oh wait, oh yeah, it's just the lens generated for us automatically for building number. So we have um, Now, adder, and then a D prime. Oh, okay, yeah. All right, so implement both ixt and at for a new type wrapper around map, which makes indexing case insensitive. Sure. So yeah, we're just gonna modify I to just be lower, and then everything will just be lower. Although I guess this technically isn't right. Um, yeah, I don't think that this is technically right, right? Because if I have this, this won't work. So load f prime. Yeah. So this is actually wrong. Um, write the x in manually. Sure. Okay, so we need to think about this because this is actually wrong. So I'm glad I found a bug. Um, all right. How do we fix this? So the problem is the map. Oh, we fixed it here, I guess, because it's saying, nah, this doesn't work either. Um, indexing is case sensitive. Okay, so we need to go look up data map. Data. So we want the strict one. Need a lookup function. How are we going to do this? So if we have, is there like a lookup with an alter, update lookup with key, adjust to adjust, insert lookup with key? Do they these things? I don't know. I'm not really sure how to do this actually, because unless you force the invariant that all your keys are lowercase, you can't just use lower. right? I'm not overthinking this. I think I'm over because the index is supposed to be case insensitive. So if we had this, then I should be able to look over it as case. Let me read this again because maybe I'm. So implement both IXed and at for a new type wrapper around a map, which makes indexing case sensitive. Yeah, so that's right. So we need to match a key as so traverse of does what? We really have no way to compare these two things. So like I'm not exactly sure how we would do this. Did I stop here? Is this where I stopped last time? Yes, it is. So that's good. Um I guess. Go here. Okay. So CI map. Oh, we never made the lenses. Well, maybe that matters. CI map. So if we make the lenses, does that get us anything? Yeah, so it's a string. And yep, we're getting an A out of it. After lowercasing the key, after and rely. I think that because we can't just lower the key, we have to lower the keys in the map. Well, let's try this solution. Hmm. I think that type is wrong. Well, okay, anyway, let's try this. So basically, well, this is just this, isn't it? Don't we need okay, is there a map keys function? Yeah, so I think that's basically what we would want. This would have to be uh, map keys. Does that thing not return a new map? Yeah, it does. Okay. Um, actual type. There we go. Then it would truly be case insensitive, right? I think so. So then this would work for f prime. Why not? Did I reload? I think I did. It still gives me nothing. Is it supposed to be also f of a? It can't be, right? Difference between this and oops, where's that coming from? String to traversal prime CI map A. Okay, so those are the same thing. That's fine. But it doesn't seem to work. So we make a CI map out of this. And then right, that should work. So let's take this. Import qualified data map as m dot map keys f map to lower import data care. Oh, sorry, didn't want to. Okay, so that does that. So we end up with should end up with this. Makes sense. All right, let's copy his code directly because I don't doesn't bunch of issues with that because didn't we? Okay, so we make the lenses. We then make the instance like so. Yeah, this is fine. And then what we want to do is have h prime and this will be case insensitive. That will h prime. Yeah. So okay, this doesn't work the way it's expected. Um, so I guess this. So okay. So let's see if we can fix it. Okay, so we're gonna make a new map. And then, well, we could probably use the simpler version of map. That's this. Then all right, that's being applied. So we're gonna say CI map lower map at uh okay, so expected type F CI map A actual. So we have having so many issues. Oh, yeah. So we do need half map here. And then this. Okay. Can't construct the infinite type. But this should really be a question mark. In which way does it go? The dot question mark or question mark dot? Oh no, it's question mark this the other way. Okay, let's try it down here. Well, let's just look at it up here. There's a map example up here somewhere. Okay, so HV. So the if we take HV, we should be able to do HV yeah, this IX Superman, right? Yes. Okay, so if we do this, oh, but the problem is that it's just is that's the issue, isn't it? It can't. can't be a just. Oh yeah, yes it can. Oh right, but that's specific. That's a specific F, which is the issue. Handler. Hmm. Let's go back to what it was before this. But this is wrong, right? That's what we've decided. F prime. Oh, wait, what? Didn't I try this? What? The other thing I want to do is check that there isn't a new version of the book that fixes this. Because if this is a problem, I should let Chris know. So I think Celine Pub and Optics by Example. For anybody interested in getting this book, you can check it out. Optics by Example is there. Um, Probably signed in version of this, which is, but I should check that there isn't a library. Oh, books. Fun. Okay, so let's get PDF again, and then let's go look at it. So we want to look at indexable structures here. Scroll down. Custom. Yeah, so I think that this is incorrect. We'll have to ask Chris about it because I'm confused. All right, but anyway, this seems to be working now. The question is, we have to fix this one as well. So let's do a similar thing here. So we're gonna say, uh, let this is obviously super inefficient, but I don't see a better way because I don't see how you make it case insensitive without making it case insensitive on the keys. Like, how would you do that? And then this can just change to lower map, and then we can also ORMLU this code at some point, but it doesn't really matter. So if we reload this, then we should also have a functioning G. So we're going to say, yeah, so this should give us something. G, yeah, just world. And if we change this to map, then, and reload this, do the same thing. Wait, why does that one work? I feel like I'm losing my mind. Save. Reload. Oh, this is this. Okay. Yeah. That's fine, right? Because we're doing at. We're setting at to world. This is okay. The problem will be if we did G double under, which is going to not be G prime, but oh well, wait a second. Yeah. So if we did this, okay, ready? And then he said at or well, ampersand at hello no world world that will set those two keys. But then if we try to index hello, this is supposed to be x. Let's just put this in parentheses because what's wrong with this? Oh, this needs to be like a 1. And then we'll try and look at the index hello. So this will set world, which will be let's do this and then reload and then G under double under is oh right, but I fixed it. Sorry. Um this needs to be this just should be map. There we go. That's nothing because the index is broken, um, which makes sense. So the at will work, but not really because if this was well, let's try. Okay, let's make this break. Um, so we'll okay. So our intention here is that we're going to have a single key hello, and it's going to be set to world. That's our intention. But if we just look at G prime, we'll have two things, hello and hello, because we've used at. So yeah, this doesn't isn't quite right. The at is okay because it's working kind of as intended, but not really. So what we need to do is actually change this to lower map, and then I think it will be fine. G prime. Yeah, this is totally fine, but it's kind of cheating, I guess. Is it cheating? No, because we're preserving our invariants. I mean, I guess I don't know. There's probably code that's designed to preserve our invariants elsewhere. You know, like when you make or add an element to this thing, it would always make sure it's lowercase. But I think technically, and again, it's kind of a dirty technically, but technically, I think this answer is correct. Unless he says explicitly, you can assume the yeah, it's right here. I'm just being silly. Done this long explanation for no reason. Welcome to optics by example, folks. Um, anyway, one thing I think we could do, I mean, we could argue that this might be somewhat of an improvement over what we had before. It does maintain our invariance, but I would guess from a what's G underscore at this point? Yeah, this is fine. Um, I would imagine that that's happening elsewhere, so probably not a big deal. All right, so now we're into new stuff. So cool. That was probably worth going through because I didn't really remember it. It's been quite a while. So the use of full traversals prisms, which we'll learn about soon. Possibility of failure, where failure is this case in this case. Depending on the situation, failures differently. Easy to determine failure cases. To Okay, so how do we determine whether an update has succeeded? The failover action helps us with this. So failover, going to take a len, a function a to b, structure, return a new structure alternative. Yeah, so this one, basically. Some traversal. Okay. It's an action, basically, the idea of preview for updates. Update function doesn't find any focuses at all, and it will return the value of empty for whichever alternative type preferred. So let's look at an example of this. So we're on H prime apparently. ABCD at failover within a traversal to upper. Will this just like work? Uh, sure. Give me 5. 8 prime. Sure. T dot text. Okay. T dot. No, that's not gonna work. Let's just use string. What? This won't try to become string? Am I losing my mind? Okay. Uh, ABCD at failover x6 to upper. There's no element at index 6, so the update fails. Couldn't match type, text, character. Okay, so make this a string. I don't know why I did that. Okay. Why does it want to be text? Okay, whatever. Let's look at the type of X. Import control lens X. Okay, so it wants text. So the applicative is maybe, and the M is probably string. So at underscore at string. And this can be maybe. And we'll get rid of this. And oops. Will it automatically do this? No. Type applications. Save this. Okay, what's this complete? Let's just do this. Oh, I always do that. Uh, type applications have to come first. Sure, just maybe. Yeah, it's the other way. So we can just probably do this. Why does it? Where is this text coming from? What is this error? Okay, so A is a string. A is a string. Couldn't match this string. Couldn't match text with car. What is this? Oh. Uh, why? Because I did that. It's right here. A special flower. So somewhere in here, there's going to be another failure. This is no longer necessary. This is probably not necessary. CD. And then we can just probably use at string here. Doesn't want to. Fine. Okay. Compiler is happy. So what's the type of this then? Oh, we're still okay. Okay, so there's call site problems. As in we can't use type applications there, would be my guess. So where is to upper used other than why did I import that from data text? That was really weird. I wasn't expecting that. What does to upper do? Oh, it did to text to. So okay. Um. Anyway, that was real. All right, so that fails. Get that. Um. So if we wanted to do A B C D failover x2 to upper. What's the type of failover? What am I doing? It's the alternative. Structure. So I guess you could do string here. No. There's no way to get the maybe out. They're all for alls. So that's the problem. Did I get rid of I did. What am I using template Haskell for? Oh. uh, oh my goodness. I'm a funny guy. I'm a real funny guy. All right, cool. So, yeah. So the bottom one will work. So H prime will give us nothing because there's nothing to change. Failover feels like a it's fine, I guess. I feel like I wouldn't associate failover with this. Like I want what do I want? What would be a with one? Probably. I associate failover with like if this thing fails, like kind of like a maybe. Like if there's a nothing, give me something. This is kind of the opposite of that. Probably why they did. All right. Notice how I manually specify the return type as maybe string dot failover. Maybe string. Failover can return its result inside any wrapper type which implements alternative. For instance, list maybe, or even IO. Although I don't recommend it, here's what happens if we change our return type to be inside IO. It will just raise an exception. That's funny. So M0 for IO is just like raising an exception. Does it work if you don't have that? So like if we do J prime ABC, well, it just copy it. And then this J and make this IO. What does this do? It's probably acting like put string. I'm not really sure. Google alternative source code. No, we don't want to go here. Instances for IO. This is what we want. M plus IO. Ooh, M plus IO. IO to IO to. We're taking. It's a string to string function? Well, it's a character to character function. I don't fully understand how this works, but okay. All right. Failover works with any traversal or prism. You can also use it with lenses if you want to, but it will be guaranteed to succeed. Really no reason. So, given an empty list, but it will be guaranteed to succeed. You can use it with lenses. All right, so this is saying if you can get the head, multiply by 10. Can't. Okay, so if we do 1 at failover head times 10, maybe int, that will work. And then if there's just like another number, yeah, sure. Um, we can nest traversals. The whole chain fails if it focuses no more element. Get A. Try to look there. Not possible. If we had x2, then it would be fine. It even works with the filters. So this doesn't match anything. Fails. Cool. Failover. Oh, we're just. That's interesting. Uh, Failover allows us to update actions when we run them, but sometimes we want to make choices based on success or within an optics itself. Here's a new toy, failing. To fold to traverse. Try to get something from index 10. Failing that, get something from index 2. I think this is supposed to be ZB, but whatever. That's fine. Is this fixed in the book? We had that open, didn't we? Probably closed it. I did close it. Just minor typo if I can remember how to update. Let's put this one in here. A little confused. M dot list. Well, it's not that confusing, I guess. But what I want to do is do the one where it fails on, or it works on the first try. 1, B, 2, close, IX, B, failing, IX, A. What if they both fail? I assume they just print nothing. But we'll try that as well. A prime, just a 2. Nice. Let's make the B. I guess it's just going to return nothing because it returns just 2, for example. So, okay. Fine. Right, nice. B. A. Sure. Very cool. All right. It works on updates as well. So, oh, that's cool. So, let's leave this here. Do I need this? Yeah. Okay. Um. Then we're gonna if B failing A. We'll just use Z this time for times 20. Mm-hmm. Works for me. Okay, so get the first album available in the map in order of preference. Oh, you can just keep going. Get Swift A tag. All elements. Sometimes when a value is missing at some particular key, we prefer to use the default value for it instead. For example, for counting the number of occurrence of unique words in a text, it would be quite cumbersome and inefficient. First, check whether we've encountered a word already. Much prefer to access and increment all in one step. In the case of counting unique words, it's semantically correct to use 0 as a default value. Making this assumption simplifies and speeds up the task. Let's learn how to do this elegantly using non. I wonder if this is supposed to be French. Probably. Anyway, non is technically an ISO, which we haven't covered yet, but you don't really need to understand ISOs in order to use it. For all intents and purposes, you can treat it like a traversal. We configure non by passing it a default value, uses the default value to build a traversal, focuses the value within a just, or in the case of nothing, focuses the default value instead. Simplest use is to unpack a provided mate. Okay. M view non-zero value non default. Yep. Yep. Cool. Non seems useful. Non and an. Forget that. This mimics the behavior of from maybe using optics. Non becomes much more useful when we combined it with the at combinator. Remember that at focuses the value wrapped at maybe, and nothing is used if the value is missing. This behavior dovetails with non to substitute a default value for missing value. So let favorite foods m dot from list Garfield lasagna I don't know who Leslie is here. Is that the other? Is that the guy's girlfriend or whatever? Wife? I don't know their names. Or what the guy's name? Okay. Um. So we're gonna say O prime at okay, so if it doesn't exist, focus pizza instead. But we'll get waffles this time. If we try and do Leo, then we'll get pizza. Fine. Favorite foods at Popeye. Spinach. How would we do this? Can we just do O prime at Popeye that, sorry, the other way. Spinach. Oh, right. We would need a question mark. Okay. So because it gives us a default value, we get adjust and then we can set. So kind of weird. Okay, so define an alias for our optic with the default value included. Sure. How would we do this? Sure. Wait, Garfield isn't stored. I need to read this. Okay, so non has an interesting behavior when setting a key to the default value. It maps the default value back to nothing, which at will be. The reason for this behavior is that so non can pass the isomorphism laws, but in the case of inserting values into maps, it still mostly makes sense. If something is the default value, it's redundant to store it. If we try to view that key later, we'll still receive the correct value by using the default. We can use this to build sparse maps and save some performance if one particular value in the map is very common. Oh, okay, that's kind of a cool. I wasn't really thinking about it that way, but that's kind of interesting. Okay, so the idea here is that with this default, if we set pizza, we try to set the value to the default value, it basically just ignores it because it's the default value. Kind of cool. And if we try to view it a second time, we get this back. This is kind of an interesting behavior. You'd use it for like a sparse matrix for or something like that, I suppose. Uh, okay, so we can modify values through non2. It behaves as we'd hope. Let's keep tally of the number of hours each employee has worked in a map. If we add hours for an employee missing from the map, they should be added as though they had logged 0 hours, the default value. Okay, so Erin will be added to the map since she's missing. Okay, so we had this. We are reaching for Erin with a default value of 0, and we're going to add 10. Because they don't exist, we'll just go to 10. In this case, we're trying to add Jim some hours, Owen day's work. Aaron had some overtime. And so Jim will just go up 8 from 32, so 40. Cool. When we pay out an employee's hours, we set their hours to 0. Non removes any keys with the default value from the list entirely. Okay, so we've paid Dwight his 39-hour work week. I just noticed that this is actually the Office characters, so that's a pretty good example. I was actually guessing if it was. I was thinking Jim and Pam, but there's Jim and Aaron, which is, if I remember correctly. Okay, cool. So checking fold success failure. We've seen how non can be used with lenses, which focus values wrapped in a maybe, like at. But what if we want to retrieve default values when focusing list indices or using an arbitrary fold? In general, you can use preview and from maybe to achieve this effect. Okay. So from maybe Z, maybe 610. Sure. But on the odd occasion we may want to run this sort of check inline, we can use non with the new fold combinator pre. Pre is a version of preview as a higher order optic. You pass it fold, and it will try to get a value. Duh. So ABC pre extend non Z. Fold, and it will try to get a value from it, returning nothing if it can't find one. Kind of cool. Isn't this the same as question dot? Let's find out. So if we do ABC question dot, wait, no. This x10 non Z. Oh, okay. Because of the way non works, that doesn't work. I was just curious. So view. Oh, and then we need pre. And then we'll put this example up here. Okay, so Q from maybe Z. Actually, let's just write equivalent to Q prime equals from maybe Z, BC. Oh, right. I tried to, yeah. Okay. We should just wrap these in this, although I don't think that's actually the correct way to do this in Haddock. I should mess with Haddock more. That's actually on my list of things to do at some point. ABC, view, pre, x10, non-zero. Oh, Z. Make this a string, then should be good. Okay, cool. Nice. We use view rather than maybe view. I don't remember what the, since pre turns the fold into a getter. So we we filter for even values and get the first one. Why is there no non here? Oh, I guess we don't wait. Don't we need a default value? What's okay? Uh what's the result if we don't have an even number in here? 1, 3, 5 are prime. That's what I thought. Dot non 2. Nice. Okay. I guess he's probably getting there, but it's odd to me that non is not included in this example until here, obviously. All right, so this one is just giving us a z again. 3 isn't very commonly used, however, I figured I'd include it here just in case you have use for it. I can't think of an obvious use case for this, but like, I don't know what to expect. So exercises. If I could spell. If I could I could spell. There we go. Okay, so write an optic which focuses the value at key first, or failing that the value at key second. So let optic pull. What are we on? Our orange. So pre is like, it's basically a way to take this thing and wrap it in a just if it can match anything. So if traverse.filtered even matches any element, it will return that the first element. It will return that wrapped in a just. Otherwise, it will return a nothing. So if we just do this, for example, then this thing will return nothing. If we write dot non 2, then it will return nothing and give us our default value, which is 2 here. So that's what pre is. Wrap the thing up and turn it into a getter of maybe something. I guess. I think I'm saying that right. Okay, so we are on S. Hopefully that answers your question. It was like a minute ago, or well, a few minutes ago. So M from list first false, second, oops, false. Yeah, no worries. I mean, it's kind of a weird thing. You know what I mean? Optic set true. Oh, this needs to get embedded. I can't write a let there. Oops. P in. I can write a let here. Apparently I've already used S. T. Okay. And then this should fail because it's obviously a hole. Okay, so it says write an optic which focuses the value at key first, or failing that, the value at key second. So this should be X first, failing X second. Okay, and so just for we'll just bunch these up, um, which is fine. I mean, it's not a really big deal. I don't need to separate them if I don't want to. So that's like the first exercise. Uh, to basically do what I want. Okay, so write an optic which focuses the first element of a tuple if I guess you pronounce the if. So we found another. We should check this as well. If I don't remember what the typo or what was on 186. Let's quickly look at that because I just don't. Oh, isn't this common? So third paragraph from. I gotta check these too because they may be updated already. Okay. Where was I? We're a little further down. All right. So here, optic focuses first element of tuple if even or second element otherwise. Whole can't write. Okay, cool. So it's definitely gonna be a failing. It's gonna be, I think, first failing. No, this is gonna be like traversed. I think it's like this. Does this actually work? No. Okay. There it goes. Takes a while to figure this out. Um, I forget how to do. So this is just even. It's not is even. But I can't remember what the first and second filters, or sorry, the lenses are called. So let's go to Google and control lens Here. And then is it like it's not very okay. First? Oh, it's like underscore one. Yeah, yeah, yeah. So this is underscore one underscore two, I believe. And then there's no way there's an even optic. But we could use I think that's a thing. Even. So okay, well does this work? I think that this is going to work, but it's not quite right. So U prime gives us 10 1. So we want to focus one, but we need to focus even, which is, can we just use filtered? Is that a thing? Really? That works? It does. Wild. Um, I was not expecting to filter. Okay, sure. So, okay, like I guess right, traverse focuses on all the elements. So I guess this makes sense, right? We're focusing on all the elements in the list with traversed, and then we're just saying give us the ones that are even. So we would our our filter would look at 2 and 4, but because we're using pre, it's only going to get 2 in this case. So I guess this makes sense. It's just a little odd. I guess that's just lenses though. You got to get used to it. Okay, so we could have this, or we could have 2 1 at optic 10 like so. Prime should give us the thing we expected, right? Excuse me. Okay, so write an optic which focuses all even numbers in a list. If none of the members are odd, then focus all numbers in the list. Write an optic which focuses all even numbers in a list. If none of the members are odd, then focus all numbers. Okay, so if there are any odd numbers, is this worded as weird as I think it is? Isn't this just traversed is traversed dot filtered even? Oh no, it's not because um okay. I think it's like this is kind of a weird one, I guess, but it's still with failing, I'm pretty sure. So v prime at optic equals, so I think it's going to be traversed dot filtered even failing traversed in 1, 2, 3, 4 to list of optic 1, 3, 5 to list of. Actually pretty amazing that I remember that like this is to list of, to be completely honest. Like I haven't looked at this in probably 2 months. I'm a pretty forgetful dude. Um, but this appears to compile, so the question is, does it work? And it does. So it's like, yeah, it makes sense. So if traverse filtered even um, gives you nothing, then it fails. So go do traversed. Makes sense to me. Okay, fill in the blanks. So this is 3 uh, optic should focus all even numbers or all numbers when no even present. Easy. Easy peasy. Let's put a space here for consistency. And 4. Fill in the blanks. All right. So yeah, so this one is just like, these are sort of yeah. Anyway, there's really not much I can do here, um, to make this easier for people like reading this code later. 7. The answer is just 107. So this filter clearly needs to be non 100. So W should be default, X should be just 107, and it is. Wonderful. Very good. X, Y. I don't want to write all this. Can you spell pierogies? I feel like there's an I in, or is that like, um, it depends where you're from kind of thing? I'm genuinely curious about that, which I know is like a weird thing to be curious about, but welcome to my world, I suppose. Okay, and then so did at broccoli. Okay, I'm gonna look that up. So pierogies. So what's the difference between these two spellings? Uh, pierogi, pierogies versus pierogies. Is that no? Go away. Sorry. Um. I don't see the. Oh, alternative name. Cool. Sure. Sorry, I had to look that up. I really, really want pierogies now. Dot underscore. So that's going to be a hole, and this thing should return false. Okay. So at is this just non-false? I think so. I don't know if there's another way to do this. Prime. Mm-hmm. Okay. Uh, Z prime. Excuse me. Oops. Put that there. And then at underscore plus 999. And the result adds. Okay. So um we have M from list, and then we have basically trying to add a value. So we're going to uh X Wario's Woods. Oh, right. The default is integer. Is this the type it's having issues with? Couldn't match the type. Maybe integer with integer. Oh, right. Okay, so this doesn't matter. It's not a problem here. It's like, can we like just write, or are we? No, because this is yeah, this doesn't work. We need to have a focus. Now, how do we get to 0? This isn't right. Forget how we set these things. Oh, we could do Wario's Woods. Oh, right. That thing has fire map. Okay. Let's go back to this. So this is a hole. The setter. 3. Could use. Oh no, because what is this supposed to be? This sets Dwight. Oh, at. Okay, so basically we're saying at Wario's Woods give us a 0 and then add 9999 to it. I think this is right. Kind of weird. Yeah. Okay, so next one is that. That one is a little tricky, but it's only because I forgot about at. Last one, math, science, geography, view, whole, non, scheduled, should return unscheduled. Okay, so x10. At. Oops. Uh, this is complaining about. Um, why doesn't this work? At the index should be an integer, right? Understand. Oh, do we need pre? I think we need pre. It's just pre x10. That makes sense, I think. So it's like um, non requires a just, so we need to sort of wrap our x10 to a just situation so that pre x10 focuses nothing, and then we just say, okay, pass that through on. My phone's blowing up. Hang on. Okay. B underscore. So this is bonus, which means it's probably difficult. Maybe. So 1, 2, 3, 4. To list of underscore A should return -1, 2, -1, 4. Okay, so pre turns things into nothing. So pre filtered odd something. Okay, so no, that doesn't work. Because what this is doing is finding the first odd number or printing -1. Hmm. Mm-hmm. To list of. The problem here is that pre gives us the first one, which is no good. Is that so? What was the thing that made it a lens on the function? I forget what that was. We did it with reverse. Is it just IX or is it at? Dude, that was was X. So hmm. Indexing into a function runs the function with the index's input. It's input. I don't see how we're gonna pass any index here. What if we did at? Hey, Pretz, how's it going? So let's make these int and then see what this complains about. I have no idea. No idea. I feel like we need to look at the answer and just see if it makes any sense. Because I don't understand this. So if we have what is our pre we want to return nothing, but also we don't want to short circuit, which is what we've been doing. I I don't really know what we would do here. This doesn't make any sense. Cause like non is not quite right. What if we do traversed dot filtered like this? So it yeah, I don't have book, but I do have optics by example. So that's the book we're working on. So what about this? What does this even do? So what we really want to do is filtered even though I think if this even does anything. Because I think well what I'm hoping this is saying is go look at each of these. If it's an even number, wait, did we already write this? I feel like we already wrote this. We print it, otherwise -1. Well, let's just try it. I mean, like, excuse me. What's the worst that can happen? It fails, right? Or well, it's wrong. Yeah, it's doing the same thing. No, actually, this doesn't do the right thing. I don't even know what this is doing. Uh, all right, we're looking at the answer. I don't know. Doesn't make any sense to me. Okay, so I think the other ones are correct. They're pretty obvious, actually. But this one is not obvious. Wait, what? That's what I have. It didn't work. Oh, I must have not saved. Okay. So I had it. I had the traversed in the wrong place. If you shove the traverse inside the pre, then it does not work because it just gives you the first. It would just give you list of -1, I believe. So I just don't think I saved it. Anyway, that's cool that I actually had this. Um, yeah, I just picked some number. He picked just 7, so it doesn't matter. Uh, yeah, so this kind of works. Cool. Questions. And so that's chapter 8. And it's been about 2.5 hours, so I think I'm gonna call it today. But the goal is that we're gonna have this. I, I mean, I think it's a pretty freaking ambitious goal, but I would really like to have this book done by the end of the year. The problem is that we have prisms, ISOs. Yeah, yeah, that's 100% correct. If we here we can just do it real quick. So um, if we shove traversed in here, it still works, but it's doing traverse over the inside of the list, and it should just this will just give us list of -1 if I understand correctly. So b underscore no. Oh, because there's an even number, it gives us a 2. If this did not have any even numbers, it would just give us, I think, list of -1. Yeah. And then if we instead take the traverse out, then we're focusing on each element of the list for which we want to filter even or give us -1. So that's why this works. Oh, wait. Oh, duh. Uh, 2, 3, 4. It does filtered first. No, it does traverse first. Oh, and even when we put it inside the list. So the idea of pre is like go find the first thing that matches, and if you don't find it, do this thing. So it's like when we put traverse inside the pre, so traverse dot filtered, uh, traversed and mapped. I actually do not. I do not know that I've come across mapped yet. Mapped. Apparently, mapped is only listed once in this book as contra mapped, and it is not. It's not in the book, so no. But it is in ISOs, so maybe a mapped is an ISO. Let's look it up. Oh, no, it's just a setter. Let's look at it. Yes. Um. So yeah, but mapped takes like a function, right? Ooh, this is gonna be awkward later. Um. Okay, I've never used mapped, so let's see if we can write this in terms of mapped. Well, I guess it's not quite the same, right? Um. So isn't that what this F is? Well, that might be over all of the values in a functor. Okay. So I guess you can actually just do mapped. Oh, but you need over. Over is this. So n. Oh, you're right. Uh, wait, is this broken? Was that the answer? Was it supposed to be traversed or traverse? Wait, didn't I just finish this? Oh, I'm not even done yet. Hang on. Wait, where did this? Oh, here it is. Oh, okay. Apparently traversed and traverse are totally fine. And I guess it's just the way that the types specialize. Yeah, I think that that's all that is. But anyway, I guess we could also do something like this with mapped. So n, if even n, then n else -1, maybe. I'm kind of just messing around because I've never used map. Yeah. So like we're doing basically the same thing here. Uh, yeah. Yep. Okay, okay. Yeah, I don't know how we would use map with to list of. I think you would use it this way. I guess you could, maybe you can write this is the same as traversed dot. No, that's not going to play nice, apparently. Oh, I see. We could try that. Um, I don't think that's going to work, but we can try it. And the error message will be extra cryptic. Yeah, I mean, this doesn't really mean anything to me.